Hello to the participants, everybody rolling in.
Most of the attendees today, they've watched the lecture from Byron this morning, and
Okay,
they noticed most of them said the front end was really nice. They said really nice UI.
I'm glad that you guys liked it. I tried to make it nice to use. So, and I hope it's useful. I hope Cyclops is very useful. This is a nice attendee list. Look at that, up to 20 basically right away. So while some people are trickling in, we're going to be looking at a Chrome extension today that helps with internet computer development. It's basically like Chrome developer tools, but it works with the internet computer. So we're going to go through a little pre-recorded section to just introduce how to get started. And then we're going to sort of put together a little bit of a methodology that we can use to troubleshoot and understand internet computer applications. And we'll go through that process in a bit of a live debugging session. And that's the schedule for today. So I think it's going to be fairly straightforward, but if you have questions along the way, fire them off into the chat and I'll try to answer them. And then there'll be some time towards the end to answer a few maybe deeper questions or take a look at some applications on the internet computer that we'd like to understand better together. So if you have an application that you've worked on and you have a particular question about it, feel free to suggest that later in the session and we can do a little bit of a live analysis together. So we'll start with the pre-recorded section and I'm going to fire this off now.
In part one of this talk, the pre-recorded section, we're going to cover just a bit of an introduction. Learning objectives for this lecture are going to be developing a couple of new skills using the Internet Computer Inspector, IC Inspector. So we're going to be able to, using this extension, understand any IC app that's running in the browser, approach improving performance for any app, troubleshoot our canisters during development and during analysis of other people's canisters, generally improve our understanding of how the browser communicates with the internet computer, and in general, become an internet computer wizard. So part one, a bit of an introduction. We're going to go over the basic installation of the extension to get you up and running. Then we're going to cover the basics of the extension, so you know your way around. And then in part two, in our live lecture, we're basically going to dive into a number of different apps and do some analysis. So as a basic introduction to the extension, you're likely familiar with using your browser's developer tools during web development, and they're awesome. But unfortunately, when you're developing on the internet computer, they're not so awesome. They need some help. So if we take a look at an example of an application, perhaps Discover, and we just open up our network tab, I'll filter requests to those being sent to the default boundary node. We can see we're making a bunch of query requests. These read state requests that we're sending are one part of an update message. So when we're sending an update message to the internet computer, we send multiple requests from the browser. We send initially a call where we pass the parameters of our update request. And then we send a series of read state requests to the boundary node, attempting to read the response of our update. So if we take a look at one of these, let's have a look at the response. We can see that the encoding doesn't really allow us to read this response at all. That's because requests to boundary nodes are encoded as CBOR, concise binary object notation, and they're also encoded as candid. So we need to decode that in order to read these requests at all. So if we go over into the inspector here, and we wait for some notifications or wait for some messages to come through, we can take a look and see that the response is much more readable. So this is a very powerful tool. I use it all of the time in my day-to-day work. I built it to scratch my own itch, and a lot of the big internet computer teams use this as well. It's also totally free, and it's open source, just in case you were wondering. It was built originally for Chrome, which means that it works in all sort of Chromium derivative browsers, Brave, Microsoft Edge. And Firefox is releasing, I believe it's version 109, later this week as of this recording. That's going to be January 17th. And this version of Firefox will bring with it compatibility for the extension as well. So let's get started by installing. And you can use these bit.ly links here if you want, bit.ly/IC Inspector Chrome or IC Inspector Firefox, and that'll take you right to the listing in those browser extension stores. Or you can just go to the Chrome Web Store, the Firefox add-ons directory, search for IC Inspector, and we should be the first result. So I'm on Chrome, so we'll do this on Chrome. The process is very similar if you're doing it on Firefox. I already have it in Chrome here, so I'll remove it, and then we can just add it again. And it really is as simple as hitting Add to Chrome. And there it is. I'll install it one more time and make a brief note on the permissions that are being requested. We're being told that the extension can read and change all of our data on all websites, which sounds like the most permissive option possible, and it's kind of spooky. It seems like too much power. Actually, we don't request, or this extension doesn't request any permissions whatsoever from the browser. Firefox actually does a better job of listing what the extension actually requires access to. So as an example, we'll add this extension, and then we can always see which extensions have access to the page that we're currently on just by opening up the extensions tab here. We can see the following extensions have full access to this page, and these extensions are requesting access. And we can see IC Inspector here, no access needed. This will be the case basically on every page that you go to. IC Inspector does not require access to the page. Where it does gain access is when we open up developer tools, and then when we go to the IC Inspector tab. At this point, it has access to network events coming through the page. Up until that point, it does not have any access. So in case you were wondering, developers are a security-minded bunch. So now that we have the extension installed, I have noticed oftentimes the tab in developer tools won't show up right away. And sometimes restarting Chrome is required. So if you don't see the IC Inspector showing up, go ahead and restart Chrome. I've also found there are certain web pages that prevent the tab from showing up, but it hasn't ever happened on a page where I require it. So for example, if I open it up on the Chrome Web Store here, I'm not going to be able to see it, but that's fine because Chrome Web Store isn't talking to the internet computer. So that's the basic installation. You can also install it manually if you'd like to. I won't walk through exactly how to do it, but just quickly, you can go to GitHub and download the latest release. And then in your Chrome extension settings, you can enable developer mode. Then you'll see a button to load an unpacked extension, and you can just drop the release that you downloaded into that. You might want to do a manual installation in the case that there's a new feature being released in IC Inspector. and you don't want to wait a couple of days for the Chrome Web Store to approve those changes. You can just go and install that manually, or if you wanted to for your own features, you can go through basically these same steps. So now that we have the extension installed, we'll go through its basic functionality. So the most basic functionality, obviously, is just to capture some messages. So we're going to open up DevTools, and then we're going to go to this IC Inspector tab, and then we're going to play around with the red recording button. So let's go back over to Discover here, and let's purge the logs that we've captured so far. And we'll go ahead and just turn this capture off, and we'll notice that no longer are there any messages rolling in. So you'll find that some internet computer applications they're very, very message heavy. You might get spammed with a lot of messages, which can cause you to lose track of the particular message that you're interested in. So what I like to do is as soon as I isolate the message that I'm interested in, I can just turn off capture, and that makes things just a little bit more sane in those message heavy applications. So capture does not start until we open up the developer tools and go to the IC Inspector tab. So if you're finding that the messages are not showing up here, then what you can do, make sure capture is enabled, and just give the page a refresh, and then we're capturing all of the messages from the first page load. So some more details on capturing messages. There is a soft limit of 100 messages. Beyond that, performance is taking a bit of a dip. So you can increment that limit if you'd like, but your mileage may vary in terms of performance that you get. And we covered stopping capture and clearing capture with the two buttons that are available. So we also have the ability to filter messages. So I'm going to disable capture. We have a number of messages here. And here in the filter search bar, we can type in pretty well anything here. So we can see we're talking to the wrapped ICP canister here. We can type in the name of the canister, and that would show up. We're calling this balance of method, filter by that. It's a very general text search. It searches through all the available fields for each message. So of course, this can be very handy when you're trying to capture a particular message. We also have access to a bunch of metadata for the canisters. And we'll take a look at this. So if we pick one of these, let's say this balance of call to your coin. I'm not sure what that is. So we pull a description from the DAB directory. We can say, oh, this is the token for SIGDAO. It's also a novel DeFi self-staking technology with a tax system that encourages holding. Interesting. We can see the controllers of this canister. We can also open up a link to the full Candid interface using Candid UI. And it looks like there's a problem with the Candid UI canister right now. It might just be for this particular canister. Let's try another one and see what we see. So this is an unknown canister of some kind. We'll open it up. Interesting. Dfinity's Candid UI canister seems to be having issues right now. Hopefully that resolves itself in time for our live coding demo. But this Candid UI can be very handy for reviewing the whole interface of a canister and poking around at it a bit. We can also see the subnet that is running the canister for this particular message. So we can jump out to the dashboard here and check up on the metrics for this subnet. So jumping out to check on the subnet is always a good first step if you're noticing some strange behavior, a dip in performance of the canister, long load times, failed requests, unexpected errors. Jump over to this dashboard, which again is easily accessible through the extension. And what I like to check on is finalization rate. If we see this finalization rate taking a significant dip, significantly and consistently below 1 block per second, then we can have some certainty that the subnet is to blame for our problems. And it could be due to increased load, could be due to a large deployment of canisters, etc. We should be able to identify what's going on here. And that can save us some time in terms of identifying that it's a subnet and not something in our code. We can see the caller. So this is the principal that signed the message. Presumably this is my discover principal. And we can also see the requests that were made by agent.js in order to fulfill this message. So we only have a bunch of query messages here, but if we were dealing with an update message, we would be able to see the original call request as well as all the subsequent read state requests. We would see when those requests were made and an aggregate of the duration of those requests. So we can see for each of the messages the total duration of requests to complete that message, which can be really useful for determining where slowness might be in our communication with our canisters. Now we've covered agent requests. So that's it for the pre-recorded session. We're going to jump into live coding and start to do some analysis on some internet computer apps running on mainnet.
There we go.
Part one of this talk, the pre-recorded section.
Just one time. Yeah, there's a couple notes in there that are a little bit out of date with the video. So forgive me for that. But let's jump into our live portion. So we're going to look at a couple of apps running on the internet computer. And to start, let me go full screen. Let's just get a little bit of a mental framework. Maybe if somebody could give a link to Vlad in the chat, that would be good, or I can throw that in there in a minute. Yeah, so let's get a little bit of a mental framework loaded up for different ways that we could try to understand applications. You know, we might need to figure out why our application is breaking on mainnet, or you know, we might have a new project, a new internet computer application that we have to integrate with, and so we've got to learn about this thing. Of course, we can read the documentation, which obviously it's a rich resource that explains high-level concepts and APIs. But it doesn't always exist. We don't always have documentation, and the documentation isn't always up to date, particularly when we're working in a field that's, you know, fairly pioneering. Another option would be just jumping into source code or talking with the developers, which is great because it's kind of as close to the metal as you can get. There isn't a lot of guessing involved, but not everything is open source, and also source code can be messy sometimes. And you don't always have access to developers. So the third option, and the one that we're going to be looking at today, is just analyzing something in production. One of the advantages of this approach is that the approach is basically always available to you with web applications. You can always open the thing in your browser and start looking at what developer tools are telling you. It also provides us with a way to isolate the specific component that we're interested in. So if we want to look at a particular feature, we can just open that feature in our browser, open up DevTools, poke at it, and sort of see what messages, what network requests are being exchanged. And this is also a nice way to just get the high level production behavior of the application without having to dive into source code. We can just sort of profile it at a high level and say, what network requests is it making? Maybe we're interested in performance. It's like, okay, well, what's the total sequence of requests that have to be made and how long are those taking? So there's a number of advantages to doing this sort of high level view it in production approach. So let's dive in, look at some apps, but I just want to touch a little bit further on a bit of a methodology that we're going to use. So here's a process that we could call a mainnet message analysis. What we're going to do is we're going to pick an application we're interested in, and we're going to choose a particular feature of that app that we're interested in. We are going to capture a bunch of messages while interacting with that feature. And then we're going to sort of reconstruct that message sequence and then start to make some statements about how the application works. Sorry, I don't think the video is frozen. I'm just not moving through slides particularly fast, but that's about to change. So we'll look at Discover first. Let's pull up Discover. And you know what else I'm going to do? I'm going to open up a notepad so that we can sort of capture our process and document it so that we have something at the end of our analysis that we can refer back to. So here's a little starter template that I've got for myself. I'll try to make that a little bit bigger so it's kind of readable. So here's what we're going to do. We're going to figure out how tipping works on Discover. So if we look at the Discover application, we can see that it has these tokens on different content posts. So it's this particular post here on the introduction of Discover, has some CKBTC, has some Ghost token, and then has some other tokens as well. So people can, the popular post will have a lot of different tips on it, and then we can provide tips to content that we think is particularly awesome as well, using this interaction down here. So we can see tips and we can send tips, kind of like a read and write operation. So let's just figure out how this works. We'll go through these questions one at a time, starting with how does Discover read tips? So what we're going to do is start to capture some messages. And let me know if this is too hard to read. I'm going to try to make this big enough so that everything is visible. But we're going to fire up IC Inspector, and I'll just bump up the size of that a bit. I'm going to make sure that we're capturing. And then look at that. We've got some messages rolling in. These are tips of content IDs. This is the method that's being called in this message, which sounds like exactly the type of thing that we're interested in here in this analysis. So we'll look at the payload and look at the response. And this seems like, the thing that we're interested in. Let me just reorganize that a bit. So I'm going to stop capture there. We've kind of found the message that we're interested in. And we can see that there's like a polling interaction going on here. So we can take a note. We can say that polls content in browser view. And then let's dive into a little bit of analysis on this message. So like I spoke about a little bit earlier, we have the candid UI, which is a nice way to just sort of, let's take a look at the canister in question and what generally it provides. So there's no registered name for this canister, and all we have is this identifier to go on. So interesting. Let's take a look at the methods that it exposes in its candid UI. So browsing through here, we have a method called all tips. That's interesting. Some metrics things. got a fee. So there's some kind of fee perhaps associated with tipping. We have methods for processing tips, processing transactions. What else do we have? We have this service address. That's interesting. And of course, we can call any of these methods from the Candid UI. So we've got this service address. Interesting. Take a note of that. Okay, and a few other things. And down at the bottom here, we can see tips of content IDs, tip of content ID singular, tip of recipient, of sender. So some query methods. All right. So we've got a little bit of a profile of what this canister seems to offer that seems to be providing tips to the Discover service. Let's take a look at the payload and at the response here. So this just looks like an array. We have an object with keys of an incrementing numerical value and then some values inside of that. Interestingly, some of them seem to be integers and some of them seem to be floats. That might just be a JavaScript quirk, but it looks like we're passing along the IDs of particular posts. So as we like scroll into view, we're figuring out what's in view, and then we're firing those all off in a payload to say, get me the tips for all of this content. And then we have our response here. So we have a big list. It looks like we've got a list of objects, and let's just go ahead and capture one of these objects. And we'll put that into our notes here so that we can refer back to this. So we'll say this is an example tip response. And we have this big field, which is kind of ugly here. So I'm just going to crop that out. That's the memo field. So we have a big array inside of the memo. And we'll just, pare that down so it's a little bit more readable. And then maybe we'll just make this a bit bigger for a second. Take a look at this. So we've got a tip, two fields, a content ID. So this presumably this is a principal. Presumably this is going to be the author of the content ID. And then we have a token, canister ID. So we're tipping with this token. And then we have another principal field here, the from field, saying, okay, this is probably who that tip is from. And then we have a transaction object, which looks like a standard token transaction that you might see across different token standards on the internet computer. So who did the transaction, who was the recipient of the transaction? And if we look at this, we can see that it's being sent to the service address that we looked at before. So that's interesting. And then some other sort of, basic transaction parameters, like when was it sent, a timestamp, and how much was sent. Okay, cool. That makes sense. So we can see basically how Discover reads tips now, right? It's going to pull content in view. It's going to call tips of content IDs. And this is sort of an example of what we get back. And then with, we would call tips of content IDs the list of content IDs. And that's basically how we read tips from Discover. All right, moving on to the next question that we have, which is how does Discover write tips? And to do that, all we're going to do is start capturing messages again, perform a couple of interactions in the UI, and then see what we get back. So let's turn on capture. And I've got some CKBTC ready to go. So we'll just give some CKBTC to this first post here. I don't know how many sats I have, so we'll just send 50. And we'll just watch our messages here to see what happens. Okay, there's a big spurt of messages. We're calling balance of, tips of content IDs. Looks like we're repeatedly sort of querying what tokens we actually have access to. So that I suppose the UI knows which tokens to show in this tipping UI. And then we have this method here, ICRC1 transfer. Let's take a look at that. So this is a transfer method. We're tipping with CKBTC. So we can presume that this is the CKBTC canister. We could go in and verify this canister ID if we wanted to. But it seems that this is the transaction where we are sending our tip. So let's take a look at the payload. And we have something here that sort of resembles the transaction that we were looking at previously that we got from the read response. We have some kind of memo object in here. And we're sending it to this individual. Interesting. Okay. And then we get a positive response back from that. So we'll just copy this out. And we basically can say we transfer funds to the token canister. And who are we sending it to? We're sending it to this this principal, which is interesting. I would have expected to see the service address in there, but it could be that this is just the principal format of this address. So we're going to transfer funds to the token canister, and we'll track an example transfer method in our file here, so we have that for reference. And now we can sort of wonder to ourselves, well, we have the transfer that we've sent, but where's all of the metadata for the actual tip itself, right? In our example tip response here, we have the actual transaction, but we also have who's receiving the tip. We have the content ID for the tip, who the tip is from, and we don't see any of that inside of this transfer. And if we sort of look through the messages, there doesn't really seem to be anything else that's indicating you know, a component of the tip. So I think an educated guess here would be to say that in this memo, we're encoding some data, some of the metadata that's of interest to us. But a memo can be encoded any way that you want, and without sort of having the encoding and decoding methods be known to us, it'll be difficult or impossible to like actually pull that information out. So that'll be the end of, or that's as far as we can take the analysis for this particular feature. But we can say we send a transfer of funds, and then we send some encoded memo with tip metadata is likely what occurs. And so the idea here is now we've got like a reconstructed set of messages where, you know, if we wanted to use this this feature sort of from our own front end, we know sort of when to call things, what parameters to send along, and what we can sort of expect to get back. So we're going to switch over to the next application now, which is going to be Sonic. So we're going to take a quick dive into that. I see an open question from Vlad. Sorry you missed it. How do you open the IC Inspector tab? So if you have the inspector installed, which again you just do through the Chrome Web Store or the Firefox Web Store, you can open up your developer tools by hitting F12. Your standard browser developer tools, and you have a whole bunch of tabs in here. The one that we're looking at is IC Inspector. So just open up DevTools and then go to the IC Inspector tab, and you should be up and running. All right, so Sonic. let's take a look. Of course, Sonic is a token swap product. It allows us to exchange some tokens that we have for some different tokens. But let's say perhaps we want to perform swaps programmatically. Maybe we want to write some code to do some swapping instead of using the UI. Well, we can use this mainnet method, mainnet message analysis approach to figure out what the correct sequence of calls would be so that we can achieve that. So I'm going to wipe out our Discover document here, and we'll start another one for understanding Sonic. We're going to ask, how does swapping work? We want to make swaps programmatically, so what calls do we need to make? Great. So the process is as before. We're basically going to open up the inspector, make sure we're capturing messages. Then we're just going to perform the interactions with the feature that we're interested in and see what happens. So we're already getting a bunch of stuff rolling in, a bunch of balance of. So it seems that account balance is just another balance fetching method. It seems that the front end is polling all of the token canisters that it's aware of in order to determine what funds do I have, what can I swap with, so that when I'm looking at the swap, looking at the swap UI, I can see my balance for ICP. There's 14 ICP in there. My balance for wrapped ICP is 3.89. So that makes sense. That's all of these messages that we're seeing there. So that's a lot. That's kind of noisy, and that can happen. So we're just going to turn that off for a second, and we're going to set up the swap that we want to make. So I've got some wrapped ICP, and I want some chat tokens. Perhaps let's get some chat tokens. So I'm just going to do a small trade of some kind, a trade like 5 cents worth of wrapped ICP, and that's going to give me some chat tokens. And I can review my swap. But first, we're going to start capturing messages. So we're capturing. We're going to say, okay, let's get going. Review swap. Yes, that looks good. Let's swap. Okay, so we can see on screen that we are going through a process of approve, deposit, and swap. So in this flurry of messages of checking balances here, let's see if we can find approving, depositing, swapping anywhere in here. And cutting to the chase, we can't see them in here. There's just a bunch of balance of. These message calls are not showing up in IC Inspector. So darn, we can't diagnose that that sequence of calls and what's going on here. Well, Sonic uses Plug, as I think it's the only wallet that it supports. And Plug, like all other browser extension-based wallets, operates in its own process and makes calls from its own background process. And so all we need to do is to analyze the Chrome extension's backend process, and we'll be able to see the messages that we're interested in. So if we go to Chrome extensions settings, so Chrome / extensions, we'll get to our list of all of our extensions that are installed here, and then we can see IC Inspector here, and we can expect the backend views. Actually, we're not interested in IC Inspector, we're interested in Plug. So the Plug wallet is responsible for making the calls, and I am just going to inspect the background page for Plug. And then we will try this all over again. So let's put this off to the side like so. Now we have this developer tools window is dedicated to the Plug background process, and we can open up IC Inspector. And let's just try it again. Do the exact same trade 5 cents worth of wrapped ICP for some chat. And we'll see what we get. All right, we're approving, and we can see we've just had an approve message. We've had a deposit message that's currently pending. This is great. So we've found the messages that we're interested in, and now we can take a look at these and answer the questions that we have. So let's just open this up. Again, the question is, I want to make swaps programmatically. What calls do I need to make? Well, here they are. We've got approve, then we've got deposit, and then we've got swap, exact, tokens, for tokens. And if we have typos in here, it doesn't matter. This is just our own analysis. Okay, so let's take a closer look at each of these messages. We've got one call to the wrapped ICP canister, and then we've got two calls to the Sonic swap canister. So we traded wrapped ICP for CKBTC. Of note would be, we don't ever make a message explicitly to CKBTC. It seems that Sonic handles that for us. So the first thing we do, we call approve. And this is on the wrapped ICP canister. Let's go and take a look at the payload. So we are sending an approval for, this looks like a canister ID, and then a number. So this looks like the amount of tokens that I wanted to transfer. And if we just, glance at this canister ID, 3XW, and then pop back out to this view here and open up the message to Sonic Swap, we can see that canister ID is actually the canister ID of Sonic. So we are approving the Sonic Swap canister for this amount of wrapped ICP 0.01. We're approving the swap canister to use those funds for us. So we can say prove. We're going to we'll change this to an ordered list. We'll say step one is to call the approve function on wrapped ICP token canister, and we will capture the payload that we're sending along. There we go. So we send that message first. Now what's going on with deposit? So we are, again, let's take a look at the payload. And we are passing in another tuple here, another array of two values, where the first one is a text value, again, looking like a canister ID, and then an amount. So this amount, again, looks like the amount of tokens that we wanted to swap. But what is this token or this canister ID here? UTOZZ. Let's go and take a look back at the wrapped ICP canister. We can see that, yes, that is the canister ID for the wrapped ICP canister. So we're sending along a deposit, and we're indicating which canister holds the token, which we are depositing, and the amount that we are sending along. So that's everything we need to know about step number 2, deposit. So we'll just flesh that out a little bit to say call deposit on the Sonic swap canister. And we have an example of what to send along in our request there. Last but not least, we have SWAU exact tokens for tokens. So let's take a look at that guy. Third and final step. Okay, so a little bit more going on in this one. We have the number of tokens that we wanted to send, the amount of wrapped ICP. We can sort of immediately recognize this. Don't immediately recognize this number here, but if we pop back over, oh, looks like the UI has already been updated, but I think we could make an educated guess to say that this second value is the amount of tokens that we expect to receive. Then our third value is a tuple, and we are indicating 1, the token canister which we are sending. And again, perhaps we could presume this is the canister ID for the tokens which we expect to receive. So we have a nice sort of symmetry between the first and second and the tuple of the third parameters of this call. Then we have a string, which looks like a principal. Presumably that's our own principal. And then a number, which once you spend some time looking at data from the internet computer, you'll immediately recognize this format of number as quite likely a timestamp. It starts with a 1 and a 6, and then it has a lot of different characters. So we'll copy that payload, this being the final payload that we need to send in order to complete a swap. And then if we look at our response, it looks like, okay, that went through. You know what? I'll fix these typos just in case that's been bothering anybody. Vlad, that timestamp is in nanoseconds. So you've got an additional 6 digits over what you'd be used to if you're used to working with milliseconds. Somebody can correct me if I'm wrong about that. Okay, here we go. So if we want to swap programmatically, this is all we need to do. We need to call approve on the wrapped ICP token canister. We pass in the tokens that we want to send and the amount of that token. Then we call deposit on Sonic Swap, passing in these parameters. And then we finally call swap exact tokens for tokens, where we describe the amount of the token we're sending, the amount of the token which we expect to receive, our principal, and a timestamp. So we could take this and now run over and write a little program in our favorite language to perform a programmatic swap. One of the benefits of doing this type of analysis is we can sort of identify any quirks. So one thing that jumps out at me looking at these calls is that we have canister IDs going on here, we have principals going on here. But going back to the payload, we can see that, sorry, excuse me one second. My headphones are running out of batteries. These are text values. I would expect them to be principal values. So there's a little bit of a gotcha there. We can take note of that. It's a good thing to put in our analysis. Principals are passed as text. Interesting. Okay. So that's going to wrap that up and bring us to the final stage for just some Q&A. So yeah, no silly questions. Anything that we covered today, feel free. And also, if you have any apps that you'd like to take a look at, then fire those off into chat, and yeah, we'll see if we can take a look at that. My headphones are about to die, so we'll see how far we get. You'll still be able to hear me. I just won't be able to hear you guys. So Seb has a question here. I'm not sure why we need to approve since we are calling deposit just after. Makes sense. Let's talk about it. So this is the sequence of calls that we're making. We're saying approve on the wrapped ICP token canister, and then we're calling deposit. Why do we need both, right? So in the first call, we're telling the wrapped ICP canister that we approve this principal to spend this amount of our funds. And who is this principal? This principal is the Sonic Swap canister. So this is the sequence of calls that the Sonic protocol has set up. There's probably other ways to do it, but they require us to approve the token canister to spend our ICP, or for Sonic Swap to spend our ICP, and then Sonic Swap itself will call that canister, and it will make use of that approval. So the deposit call that we're making here is not actually a call to a token canister. We're calling the Sonic Swap, which then makes a call to the token canister on our behalf. Hopefully that makes sense. So could you show how to show only the backend part? Sorry, Luis, if you could maybe just repeat the question again for me one time. I'm not sure I grasp what you're after. If you could clarify that for me, that would be great. And Vlad with another question. I love it. Thank you for the engagement, Vlad. How do you use the IC inspector to find the session key after logging in with II? So the session key. Curious what exactly you mean by session key, but so you can store it and check for it at the page load event. Yeah, so I'm not sure which session key you're referring to. I could take a guess that when you log in with internet identity, it creates a principal that's unique for you at that specific domain. So your principal at Discover is different from your principal at the NNS app, etc. So if that is that principal what you're interested in, Vlad, or is it something else? Okay, it's the principal. So what you could do is if we open up IC Inspector here, and these are just a bunch of calls that and wrapped ICP, but in the overview for the message, we can see the caller. So the caller is the principal, which has signed the message, and that's on behalf of us. This is our principal. So this principal here is my plug principal, and my plug principal is consistent between all of the different applications that I might connect to. Like I said, that's different for internet identity. You'll have a different principal each and every time, but all you have to do would be to go to an application, capture a message after you log in with internet identity, and you'll be able to see your principal that you made that call with inside of the caller field here. Hope that helps, Vlad. Yeah, great. If there's any other questions or apps that people would be interested in taking a look at, please feel free. I'm just going to scroll up in the chat and see. So Wilman Venueza, you have a question, which is, what would be the equivalent of MetaMask in ICP? There's a number of browser-based wallets or browser extension-based wallets that's the same architecture as MetaMask. What would be MetaMask in ICP is maybe more a question of like which wallet provider is the most established, most popular, and there's a few out there. NFID is very popular, and in fact you can connect to an internet computer application using MetaMask via NFID. So NFID might be something for you to look into, but full disclosure, I'm a little bit biased, and there are a number of wallet providers in the internet computer ecosystem. Okay, yeah, we can take a look at Kinnick, Vlad. We've got a few minutes. Again, my headphones will cut out at some point. I thought I had them charged, but perhaps they'll take us to the end. And then Luis, thank you for clarifying how to only show in the IC inspector the backend calls. Okay, so yeah, I hope so, Seb. So you only want to show backend calls in the IC inspector. Fundamentally, the IC inspector is only going to show you like something that you could consider them calls to the backend. These are all calls that go from your front end, and they're all being sent out to the internet computer blockchain. So any message that you see inside of IC inspector is a call from the current page that you're on to the internet computer blockchain, and specifically to the canister and with the method and parameters that we see in IC Inspector. So in a sense, they're all backend calls. And if I still haven't gotten to your question, then feel free to ask again, and I can see if I can give you a better response. All right, so we got a few minutes. Let's pull up Kinnick and have a look. I don't know if I've ever done this before. I did pull up their white paper recently, but I didn't get through too much of it. So we've got our IC Inspector open and ready to see what kind of messages we're sending. And we're talking to the Kinnick front-end application a bunch, we can see, sending all of these HTTP requests. And then we are also sending out a call, get canisters by PK, to whatever this is, whatever that is. And we don't have a description for it, so we can maybe just open up the Candid interface and see what it provides. Okay, so auto scale service canister, create service, get owner. Interesting. Some kind of like auto scaling canister. Maybe we'll hear from that guy again when we do an actual search. So perfect. I was about to say, what should we search? And Vlad, you've already got something for me. So do a search that returns many items like NFT or marketplace. Let's just search for NFT. See what we get. Okay, so Kinnick is mercifully light on the messages that it's sending. Hopefully it's not too light. Hopefully we can actually find something interesting here. So we've got another canister that we haven't spoken to yet, NW5. And so again, we can see we're calling this anonymously. We're not connected. So that's interesting. And we're calling for parallel on this NW5 canister. Let's open up the Candid interface here and see what we have. Category search, newest, get next keys for parallel search term, get PK, search canister ID, search category, search term for parallel. Okay. And what are we sending along here? Great. All right. So our search query just gets passed into this search term for parallel function. And curious, why we're using search term for parallel instead of, we just have like this search term option here. So maybe we can figure that out. And then if we look at the response that we're getting, we're getting a big old response. And, I'm going to copy this and we're going to open VS Code and maybe parse this a little bit better. And we'll paste this in, change language mode to JSON and bump up the size a little bit and then try to format the document, see if that makes us any better. Okay, so what we have as a response is 2 items. The second item is a list, and perhaps we can correlate this list to the results that we're seeing on the page. So over here, the first thing that's showing up is Cthulhu game, which has this canister ID here. And this second list doesn't seem to correlate directly to the responses, but this first list does. So it's spitting out results for us. We've got the canister ID, the subnet that it's on, the type of application that it is, something called last seen, data length. We've got a title, subtitle, all these things for rendering out our results. And content for rendering out our results. We have app type, we have a note, we have status, broken count. Okay, so all we have is like a search result, right? And it's pretty easy for us to tell like how we can query Kinnick. but there's not a lot of like other use cases that we can analyze using the front end of this product. We can jump off to all these things, but like we're kind of just using the search functionality. And I think, you know, to understand Kinnick, obviously this is just like the part that we interact with. They're going to be doing some interesting indexing stuff on the back end. And we're not going to be able to see that by, you know, just poking at the app in production. What we could do is perhaps dive into this canister a little bit more and see what else is exposed and maybe learn something that way. But I think, you know, poking at the front end in production here isn't going to be the #1 best way for us to figure out like the back end architecture for Kinnick. Probably like reading the white paper and seeing as it's got an SNS coming up, as I think I heard, you know, there should be some open source resources for us there. But yeah, Vlad, you asked a great question. Search term for parallel. So yeah, basically you call this method, right? And that's how you can get responses from the canister. Yeah, good question, Seb. What pops up if we try the normal search term with the same NFT term? So if we just go over to the candid interface, it's an awesome question. Search term NFT query. Let's see what we got. So let's look at the return types really quickly, right? We've got search term takes text and then an optional text as well. And then it returns a text and an optional text response, and then search term parallel. We scroll all the way down past this really quickly. Here, search term for parallel has a different call signature, so we pass in a vec text instead of a text and an optional, and then it responds with text and vec text. So like slightly different call and return signatures there. And we can get text. Let's copy this again and put it into something that's a bit easier for us to read. And let's see. I should probably format this as JSON. Let's see. Yeah, let's format this as JSON. Just raw text, JSON, or maybe we could open it in the UI. That's not particularly helpful, actually. Copy, paste that here. Language mode, oops. Language mode should already be JSON, but let's just double check, try to format that. Okay, kind of a similar story as before. So we get a much shorter response for the second item here when using that normal just search term method instead of search term for parallel. But then looking at the responses, so far seems to be the same, right? This is the canister that we saw before: subnet ID, type, data length, last seen, Cthulhu game, same type of content, app type game, note. Yeah, this is the exact same response upstairs, but we got something different back for this second parameter. So maybe maybe somebody can tell what the second parameter is. So type app score 32. Canister ID. Did we get a shorter list back? No, we still got a bunch of responses back in the first parameter. Yeah, I'm not sure what the difference is, to be honest. Slightly different response, but quite similar. Okay, I'm surprised my headphones have made it this far. If there's any final questions, fire them off. Thanks very much for coming, guys. I hope that you find this tool useful, and especially big thanks to all the people who showed up in chat and asked awesome questions. So that's it. Thanks.
Thanks for showing
take
up.
care.
I've learned a lot of things today. actually.
Good.
Very good.
Yeah, I even learned a few things.
I see you in the next. So in 2 hours, guys, we have latest mentorship session. I'm going to correct the correct. I'm going to give you some hints for the latest projects that you have to work on. So I see you there, and good luck. Thanks.
Okay, thanks, Seb. You guys are in great hands with Seb. Good luck with the boot camp, and good job for sticking it out. You know, it's not the easiest thing. So great work for sticking it out this long, everybody. And good luck with the rest.
Thank you.